Okay, so we have this question here about the number of days it takes for one of these things to orbit Earth and the distance they are from the Sun. Orbit Earth, orbit the Sun. So it takes Mercury 88 days to orbit the Sun, and it's only 58 million kilometers from the Sun. Now it's very obvious here. I'm going to suspect, or it gives us a bit of a hint that we need to do a log-log graph. The hint is right here where it says use a log-log plot to find the relationship. So it's very subtle. To find the relationship between the period of the object and the distance from the Sun. Now, with this question, the first thing I want to do, I'm going to call period P, and I'm going to call distance D. And which of these variables is the independent variable? So which one of them is the x? Distance is the independent. Distance, that's right, because the period depends on the distance from the Sun. Okay. Now this one is, this is a time, so you'd think normally time is independent, but in this case distance. So I'm just going to write on this sheet the distance is the independent, so it should be the period. Now, if it's a log-log, what sort of function is that? It's a power function. Yeah? So the period should be a d to the n. So we're going to end up with a power function. Okay? However, we're not quite there yet. Okay? So the big idea with this now, although it's really obvious what we think we're going to end up with, we actually, because we're mathematicians, we have to work this out before we actually make that assertion. There's a significant overlap between maths and physics. Anyway. Okay, so I'm going to copy out part of this table. So we have 9 entries here. We have 8 planets and 1 Pluto. So I'm just going to use 4. So I'm going to use Mercury, Earth, Saturn, which is the best planet, and Neptune. So we need a planet. We're going to have the period, and because it's a log-log graph, guys, because it's a log-log, I need to take the logs of both of my variables. Okay, so I have a row for P, I have a row for the log of P, I have D, and I have a row for the log of D. So we have Mercury, which is 88, and the D for Mercury is 58. We have Earth, which is 365 and 150. Jupiter. No, I said Saturn. I like Saturn. Which is 10,759 and 1427. And Neptune, which is 6191 and 4497. So this is the data we need now. You'll see what we do. We only really need 4 points. So we have the log of P. So for this row, all I'm going to do is I'm going to take the log of whatever's in this row. So I've got my calculator here. I'm going to go log of 88, and now I'm going to take it to 3 decimal places because I need it to be fairly precise. So I'm going to go 1.944, log of 365, 2.562, two. 780. Okay, so this is my P row, this is my log of P. This is my D row, And because this is log, I need to log that row too. So I'm going to go log 58. Okay, so I've filled out my table here. Now, I've got my two variables here. Now, what I need to do to show, now, they've given us a big hint that it's a power function by telling us to do a log-log plot, but, you know, I don't really want to trust them because all they've done is written the maths textbook. But what can I do to show that this is a power relationship? Sub it in. If I subbed it in, I have to sub in all 4 points. That might get a little bit time consuming. Would be valid, but there's another easier way we can do it. Maybe something visual. I think I heard a graph. Yeah. So I can graph these points. Now, usually when you're doing one of these, on maybe a piece of assessment, there should be some graph paper for you to use, a little axis. Because I don't feel like doing that, I'm going to make my point on Desmos. So I'm going to stop the recording here and I'm going to pick it up after we've looked at the Desmos graph.